Now we are starting question number 2 of this mock 2024 9709/41 is the code of that paper. The question statement is a particle of mass 0.5 kg starts from rest and slides down a line of the greatest slope of a smooth plane. The plane is inclined at an angle of 30 degrees to the horizontal. Find the time taken for the particle to reach a speed of 2.5 meters per second. When the particle has traveled 3 meters down the slope from the starting point, it reaches a horizontal surface ground at the bottom of that slope. There is a frictional force acting on that particle which is 1 Newton. Find the distance that the particle has traveled along the ground when it comes to rest. So this is question number 1 of that. Since we know that the plane is like this, making an angle of 30 degree with the horizontal, and the particle is at this position, and let's say it starts from rest, it comes towards downward B there. Since this surface is smooth, so first we are going to solve this into components. It is R, it is mg cos theta, and this is mg sin theta. Since this is the frictional force which is equal to 0, because frictional force is given there equal to 0 for that part. Since u is equal to 0, v is equal to 2.5 meters per second, and we are going to find out first the acceleration for this part A there. We know from this that the equation driving force minus resistive force is equal to net force. This is the we were going to use for this part there. Driving force is mg sin theta minus frictional force is equal to ma, or mg sin theta minus 0 is equal to ma. M and M cancel, so A is equal to g sin theta. G is 10, sin theta sin 30, so that is equal to 10 into half, and that is equal to 5 meters per second square. But we are going to calculate the time from A to B, its motion there. Since final velocity at the B point is 2.5 meters per second, initial speed is there at A is 0. So from this equation, V is equal to U plus AT. V is 2.5, U is 0, acceleration is 5 into time t there. So t will be equal to 2.5 over 5, and that thing is equal to 0.5 seconds. This is the first part of that question there. Now for the second part, they said that when the particle has traveled 3 meters down the slope, so that means what? This S from A to B is basically equal to 3 meters. And we are going to calculate the new acceleration for that. Let's say the particle after this point B, it is going to reach at this point C there. And there is a frictional force acting on that part. So here it is R, it is weight, this is frictional force, and this is the driving force which is 0 there. Now we know one thing, that the frictional force at B to C is equal to 1 Newton. Now first we are going to calculate the deceleration from B to C, because at B the new acceleration will be there. So first, driving force minus resistive force is equal to net force. Now driving force is 0, resistive force is the frictional force, is equal to m, that is 0.5 into acceleration there. So a is equal to minus 1 over 0.5. So that is equal to minus 2 meter per second square when it is coming downward on that slope there. Now, when we are going to basically calculate, it has moved 3 meter down the slope, and you are going to calculate since the particle has traveled 3 meter down the slope, so you can calculate first from this B to C at this final speed is 0, and you are going to calculate the speed at this point. We know that v square minus u square is equal to 2as. V we don't know, u is 0 there, is equal to 2 into acceleration is 10 into distance is 3. So v square is equal to 30. So v is equal to 30 square root meters per second. So at this it is equal to 30 meters per second, and finally it is what? 0 there. And now they are asking that how much distance it has traveled from B to C. So we know that 2as is equal to v square minus u square. 2 we know, a is for this downward acceleration, it is minus 2. S there is, we are going to calculate v square is 0 minus this is 30. So S is equal to minus 30 over minus 4. So minus minus cancel out. So this should be equal to 7.5 meter distance it has traveled from B to C position for this question number 2 there.